Okay, vectors look at direction and magnitude. When you complete them, they typically form a triangle, which we can then solve using SOHCAHTOA, Pythagorean theorem, law of sines, law of cosine skills that you already have. Vectors are typically taught in most places in physics classes. Here we teach it in math and in physics, although somebody in my last class told me that they didn't go over the formulas in physics, so here we will. Okay. Vectors are denoted with one-tailed arrows above the letter. Okay, so it's hard to see from the copy, but it looks something like this. Okay, and that's how we know that it is a vector. Point A is known as my starting point, okay, also initial. It is the initial point. And B, where the arrow is known as the terminal. Even though B does have an arrow on it, and typically, you're taught that that means it continues on and on, we can get coordinates and do math with those coordinates. And that's what we're going to focus on today. Okay? So we have start A, so initial, terminal B, and they want me to draw in the horizontal and vertical components. So when I do that, that is basically saying go horizontally and then go vertically until you reach the other point. Okay? So you've probably heard the shortest route between any 2 points is a direct line. But when you're on the road, there's not a direct line. Roads go, you have to go out one direction and then turn. So that's what this is. So my horizontal would be like this, and my vertical would be like this. So I went horizontal so many streets. Well, how many streets horizontally did I go? How far over? I went over to B, right? So this would be the distance of B, right? And then this would be the height. Sorry, the height of A over. I should have given coordinates and then you could see the exact distance. Yes. How do I know which way to go horizontally? I'm trying to go the most direct route to B. So I could have gone vertically first and then horizontally. Doesn't. It will eventually. It'll tell you specifically which way it wants you to go. Okay. But it did say horizontally first, so that's why I went horizontally and then vertically. But technically, both would be the right answer. Okay? All right. So when we get into some addition and subtraction in pictures, you'll see. All right. So now we're going to talk about magnitude. And magnitude is simply the distance formula. You saw the distance formula in geometry, yes? All right. The distance formula is what? No, y2 minus y1 over x2 minus x1 is slope. What is the distance formula? Yep. Excellent. So I'm going to take the square root. I'm going to find the difference of my x, square it, and add it to the difference of my y coordinates, okay? Using that formula, and these two ordered pairs, CD, right here, I would like you to find the magnitude or the distance from C to D using the distance formula. Try that now, please. Okay, so I have the square root. I have 7 minus a negative 2 squared plus negative 3 minus a negative 1 squared. 7, double negative means I'm really going to do what? Add. So that gives me, does it matter? Doesn't matter as long as this is an ordered pair and this is an ordered pair. We'll still get the same exact answer. Watch. And also because I'm squaring it. Okay? So 7 minus a negative 2 really becomes 9 squared, which is 81. If you did the negative 2 first, negative 2 minus 7 is a negative 9, and square it still gives me 81. What matters is that the first term in each are from the same ordered pair. The second terms are from the same ordered pair. Okay. It does matter, however, in slope. So then, because slope is not squared, okay? So then we have negative 3 plus 1, which is negative 2 squared is 4. So my final answer is the square root of 85. And for those of you that typed it all in your calculator as one item, you would have gotten 9.2. Good? Easy so far? Okay. Let's move on. Okay, so we can do 3 different operations with vectors. We can add them, we can subtract them, and we can do scalar multiplication. Scalar multiplication, think of it simply as distributive property. We will not do multiply at this point, we will not do multiply a vector times another vector. That gets into matrices, and we will get into matrices in a later unit, okay? It's not now. All right, I want you to take your best shot at figuring out what u plus v is. Don't overthink it. Try u plus v. I want to see what you do first, and then I'm going to reveal the answer. All right. So in a minute, I'm going to reveal the answer, and you're either going to clap because you got it right, or you're going to cry because you got it wrong and you're frazzled. Okay. So I am going to do 1 plus 0, and I'm going to do negative 4 plus 8 for a final answer of 1 comma 4. So if you got it, well, I should have heard a clap if you got it right. There we go. All right. Easy? Okay. Oh, sorry. Okay. So remember with subtraction, the order does matter. They want vector u minus, vector u minus vector v. So go ahead and do that now. All right, I think you should have had enough time. So I am going to do 1 minus 0, negative 4 minus 8 for a final answer of 1 comma negative 12. Good job. Now, this here would be scalar multiplication. I want half of vector v. Half of vector v. You don't even need time. I want half of vector v. Okay, first of all, vector v is what? What's the order pair for vector v? 0, 8. So I want half of it. What are you going to tell me? 0, 4. Because 1 half times 0 is? And 1 half times 8 is? 4. Still liking this topic? Yep. Okay. Let's move on to sketches. Okay. I am given this original sketch right here. Whoops, bad highlighter color. I am given this original sketch here. Okay, before we begin, can someone tell me what direction compass-wise u is facing or pointing? It is pointing northwest, and v is pointing southwest. Great. They would like 2v. So which way is v facing? Southwest. So I have v pointing southwest. What did I just make a sketch of? V. What did they want? 2v. Bam. 2v. That's it. I went v and v again. 2v. V and v is 2v. Yeah? No, no catch, no catch. Nope. Okay, so now we're going to do letter V. They want 2v, so I'm going to head which direction? I'm going to head southwest, the distance of v, and I'm going to do it how many times? Twice. Okay? And then after that, which way do they want me to head? Northwest, which means I don't just tack on u here. I have to tack it on in the correct direction. So I'm going to point northwest u. So this is my 2v, and this is my u, correct? Yes, question. Don't worry, you only need the top one. Yeah, I know on your paper you have 2 graphs. We're just doing the top one. Okay, so I traveled 2v, and then I traveled u. Direction does matter, okay? At the end of an arrow, you can put a tail into an arrow, okay? All right, now, technically, though, This dotted line is 2v plus u. It is the distance. Okay? So this would give me the distance, the diagonal. That's why solving triangles and stuff that we did previously is going to be important. Okay? Especially when we get into real life problems. Yes, ma'am? Yes, because if you had done that, it would have just completed, it would have given you the parallelogram effect, so it would have been up here, and then I still get this diagonal line. If I traveled u and then 2v, it would have looked like this, and then remember, 2v plus u is the diagonal, there would have been the diagonal, okay? So, yes, for addition, order doesn't matter, subtraction it does, okay? So, I'm going to rewrite this, though, as addition. It is really u plus a negative v, okay? When you take on jobs in other math and other subjects, you learn that the negative is purely there for direction, okay? Reflection, when we first started this year, we talked about reflection, change of direction, okay? All right, so first thing I'm going to do is mark u. Which way does u face? So I'm going to make my northwest, here's u, okay? Again, if I wanted to get really technical, I would have gotten out a ruler and measured how far it is, but we're just making rough sketches today, okay? Then they want me to do the opposite of v. So right now, v is headed which way? Southwest. The opposite of southwest is northeast. So now I'm going to head northeast. Northeast goes like this. So there's my v, right? And then this dotted line becomes u minus v. Sorry, my u's and my v's look the same. Everyone good? Yes, ma'am? It's just a rough sketch. Sorry, it is a little bit longer than v should have been. I was just quickly sketching. Yes, ma'am? The diagonal line is the solution to the problem. It's not always going to be the origin. That's a good, yeah, that's a good question. It won't always be the origin. Okay, so those were good questions. So now, yes, in these cases, the answer was always a dotted line and it came out of the origin. Don't always assume that. Sometimes we won't have a coordinate grid. We'll draw pictures based on word problems, but the solution is the diagonal, okay? All right. Tonight, if you look in example 4, 4a says 2v, and they give you some coordinates, okay? I simply want you to do the calculation. Don't do the magnitude because I did not do a magnitude of a single element today. I'm going to do that tomorrow because we were short on time. So, if you look at example 2a from the front, when we did u plus v and u minus v and stuff like that, you're going to apply that. You're going to do that for A, B, C, D. That is your homework. Be careful in number D. Remember to distribute first and then do the subtraction. Order of operations. Everyone good? Question. Yes, ma'am. You're distributing. So think about when it was half of D. On the front side, when it was half of V, we multiplied each piece of the ordered pair by a half. So you would multiply each piece by 2. Other questions? Whatever variable it tells you. Good? All right.